All right, last problem on your quiz 5, number 3. You have this is like the most straightforward in my opinion. It's just turning a crank. You have a surface. You're supposed to classify all the critical points. First step is to take the derivatives, the partial derivatives, set it equal to 0. So gradient of g, if you want to think like this, it's 3x squared minus 3. That's the partial of f with respect to x. And the partial of x with respect to y is the second component. You get 2y. Set them equal to 0. I get 3x squared minus 3 equals 0. That's my equation 1. And equation 2 is 2y is equal to 0. One of these is usually easy. Number 2, I just get y equals 2 gives me y equals 0. So that's a box off. And then I pop that back into, I don't have anything to pop up. This is too easy. 3 times x squared minus 1 equals 0. Factor, so you get everything. And I get x is minus 1, x plus 1 here. Ignore the 3. I get x equals 1, x equals minus 1. So my two critical points are -1, 0 and 1, 0. Next step, you take the second derivatives. So gxx is going to be, this was fx right here. Gx, I guess they called it g. Gxx would be 3 times 2, 6x. That's the second derivative. Gyy is equal to 2. And the mixed partials, which are the same, is equal to 0. Let me see if I have that correct. It's actually, sorry, this is going to be, yeah, it's 0. Because if I hold, they're independent of each other. Then if you want to use the Jacobian method that I showed you in class, you would take these things and calculate the determinant at the point. So you have to do this critical point by critical point. So let's do this first for the first critical point. CP, I'm very good at labeling these things. So CP minus 1, 0. So x equals minus 1, y equals 0. At that point, the Jacobian looks like 6 times, it'll be negative 6 right here. Putting in x equals minus 1 to gxx. And then gyy is constantly 2. This, zeros uncross, I get minus 12, which is the determinant in this case. I go to my little table down here. If the d is negative, it's automatically a saddle. So minus 1, 0 gives a saddle, however you want to say this. So let me pop this back up. Then let's go to the second derivative. I'm going to erase this so I have all my work on the same page. So you can pause me, thank goodness. So let's go to the other critical point. The other critical point was CP equals 1, 0, or x equals 1, y equals 0. In this case, the Hessian or the Jacobian, whatever you want to call this, is going to be 6, 2, 0, 0. So the determinant is 12. That's positive. And 6, gxx, is positive. So I just go down to my little table here. The determinant is positive, and the second derivative is bigger than 0, so it's a local min. And so you write your conclusions down. Straightforward, turn the crank. It's actually, I think this is probably the easiest one out of the 3 you were asked.